Hey guys, Mr. Kyle, my Irish Mathematics, and let's just jump right into it. So today I want to talk about how to graph any line. So all we're going to do is we're going to just graph a bunch of different lines. I purposely picked some really good ones with different slopes, so that way you can get an example of each kind of slope and y-intercept kind that you could run into. So that way you'll be ready for any kind of trick that they throw at you. Unless they get really creative, and then you probably just have a teacher that doesn't like you, and I'm sorry. I'm just sorry. So anyways, let's go ahead and start with this first one here. This is probably the one of the easier ones to graph, and I think it's one of the easier ones because it already has the slope as a fraction. So that 1/2 number that you see there is the slope. The top number, the 1, is the rise, the bottom number is the run. And that's how the slope always works. So there's not really a reason why it's rise over run versus run over rise. They just somebody decided that it would make more sense to do rise over run. So that way we could always just measure it the same way. If you want to know how slopey something is, how much it slopes, like, you have a wheelchair ramp that's like not very slopey, and then you have like a half pipe that's like really slopey. Well, it starts off and then it gets like really slopey. And then there's everything in between. So in order to measure how slopey something is, mathematically what you do is you take, well, how much does it go up and how much does it go over, and you divide those two and it tells you how slopey something is. So a wheelchair ramp would have a slopiness of like less than 1. But a half pipe, when you get closer to the top, it would have a slope of like 3, 4, 5, or 6, a bigger number. So that's kind of a little bit of a background before we get started, but let's go ahead and start. So the slope, actually, you can't graph not without knowing where to start. You can't just start at the origin every time. Not every line goes through the middle. Well, in order to know where, you need this thing. And this form, I have them all in the same form, so this video is about the same exact kind of form. It's called slope-intercept form because it gives you the slope and then the y-intercept. It's called slope-intercept form, but the intercept is always a y-intercept. So you go up or down to get to the point. So starting at the origin, there's the origin. We're going to go up 3. It's plus 3. So I'm going to go up 3. So I put a point right here. So you actually start with the second number, which is why this can be a little confusing sometimes, because you're like, oh, shouldn't I start with the first number I see? Well, that's how you would do it if you're like reading something, right? You read from left to right. But math, it's not always that way, unfortunately. So you actually start with the number that's not connected to the x, which in this case is the 3. So we go up 3, put a point, and then we can use the slope to get to the next point. So I would rise 1, like we talked about earlier, rise 1, run 2, right there. And I can actually do it again and over and over and over again if I want. Rise 1, run 2, and just keep going on forever. Actually, it's the same thing if I go like this, right? Go down and left, down and to the left. Won't talk about y just yet, but it would look something like that. And then you just kind of put some arrows on it. So you only really need 2 points. If you have 2 points, that's all you need for a line. But once you've graphed those 2 points, you just throw your line through it and you're good to go. And that's it. We've graphed it. So let's look at another one. Let's say we've got 2x minus 1. So 2x minus 1. This time, the slope is not a fraction. So we'll talk about it in a second. Let's graph the y-intercept first. The y-intercept is minus 1. So remember, the y-intercept is always up or down. Minus means down, so I'm going to go down 1 from the center, and there's my point. And then I've got a slope of 2. So actually, let me scroll down a little bit so you can see this better. If I have a slope of 2, well, how could I write that as a fraction? Well, what I could do is I could divide it by 1. If I divide 2 by any other number besides 1, it's not really 2. But if I divide 2 by 1, it's still just 2. So if I divide 2 by 1, it's still a 2, which means I didn't change the number. I just took the number and turned it into a fraction without changing the number. 2 over 1 is 2. 2 divided by 1 is 2. So there we go. And you have to write the number as a fraction if you're going to find out what the slope is and actually use it, because you have to go up and over every time. So you have to have your slope be a fraction. If it's not a fraction, you have to turn it into a fraction. And you can turn any number into a fraction, right? If it's not already a fraction, you just write it as that number over 1. Works on anything. So since it was just a 2, it's now 2 over 1. So we've got our y-intercept. It's right here. It's at negative 1. And then I go up to 1, 2 over 1. So right there. And then I can do it again and again and again, right? But I don't really need to. I can actually did an extra point that I didn't really need to do. Could have just stopped right there. And there we go. I've graphed my line. All right, let's look at another one. What about this one? Well, this doesn't seem to have any number at all in front of the x. So, well, I don't know. Let's start with the 5, I guess. Plus 5. So I would go up 5 from the middle, from the origin. There's the origin. 1, 2, 3, 4, 5. So put a point right there. So now let's figure out what we can do about the x. So if there was no number, one thing a lot of people think is, okay, if there's no number in front of x, is it 0? Well, if it was 0, then I would go like up 0, but still over 1. So I'd still have a line. But if it was 0, I actually wouldn't need to have an x there at all, because 0 times anything is 0. So even though we don't know what x is, if it was 0x, then there wouldn't be an x. But there is an x. And here's the trick. If you have x, y equals x plus 5 in this case, if you have an x, then how many x's is that? Well, it's 1. There's one of them, right? So the way to think about it is like this, like this pen, my stylus that I use here. This pen, if I were to like hand you this pen, I would say, would you like a pen? And hand you the pen. I wouldn't say, would you like one pen? Right? That'd be weird. Nobody says, would you like one pen? People say, would you like a pen? Right? So I have y equals an x plus a 5, which means I have one of them. And then, of course, if I have 1x, I can take that number and write it as a fraction. So anytime you see an x, the slope is rise 1, run 1. Because I have 1x, if I have an x, then I have one of them. And any number can be written as a number over 1. So it's 1 over 1. So rise 1, run 1. Boom, 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 boom. Right, I can keep going all the way if I wanted to, but I'm not going to go and go and go, because you can kind of get the picture there, right? So there we go. Then we have negatives. This is the first time we've done a negative, so let's look at what that would be. Well, also, another little curveball is there's no plus something or minus something. So there's nothing here. Well, this time you would say, okay, well, if there's no number in front of the x, that means there's one x, right? But if I'm adding something and there's nothing there, should that be a 1 or a 0? Well, it would be a 0, not a 1. If you're multiplying, you can multiply by 1 and nothing happens. So there's like an invisible 1 when you're multiplying. When you're adding or subtracting, there's like an invisible 0. You got to be careful. That's the tricky part. If there's no number in front of x, then you have 1x. There's one of them. If you're not adding anything to x, then you're adding nothing to x. You're adding 0 to x. So I would start at 0. So if there's no number, then it doesn't mean you can't graph the line. It just means that you start at nothing. You start at 0. You start at the middle, the very middle of the graph. So if you've got nothing added or subtracted to x, you would start at the middle. Now, this negative 1/2 x, the best way to think about it, and I'll rewrite it like this. the best way to think about this is to always, this is definitely something worth writing down if you're in algebra watching this, is that if you're going to have a negative 1/2, you want to put the negative at the top. Always put the negative at the top, because it makes more sense to say rise -1, and then you're like, oh wait, rise -1, that means I should go down. Like rise negative, I should fall by 1. Like -1, fall, like rise -1. Okay, that's the opposite of rise is fall. So fall down 1 and then go right by 2. So that way you can get it, you don't get it messed up. Because if you always go to the right, like it's harder in your mind to be like, oh, going left is negative and going right is positive. Like that doesn't make as much sense in real life, because it's like I can turn left or right. Like when you're driving, right? It's not like negative if you turn left. Like there's nothing wrong with turning left. But if you're going to go up or down, like that makes more sense, right? Like whatever goes up has to come back down. So always put the negative on the top. It's just going to make more sense to you, because in real life, it makes more sense for there to be like up is positive, down is negative. So if you make the negative go to the top every time, it'll make it a lot easier. Plus you'll be consistent, and if you're consistent, if you like do the same thing, if you solve it the same way each time, assuming you get the right answer, then that's going to be a lot better for you. So -1/2. So I'm going to rise -1, which means I'm going to fall 1, run 2. Fall 1, run 2. So actually notice this graph looks different than all the others, because the line is pointing the other way. It's going down, right? So let me show you. That line is pointing up, right? It's sloping up, like it's kind of traveling up and to the right, up and to the right, up and to the right. They're all traveling up and to the right, except for this one. This one's going down and to the right. So that's the way to know if you've done it right. If you have a negative slope, it should be going down. If you have a positive slope, it should be going up. Right. So let's look at this one. This is next. So this one actually represents a bunch of different things they could do. So if they give you an equation that's it's not simplified yet, then you have to kind of do some like simplifying first before you can graph it. So sometimes they'll give it to you where it's like you have to clean it up a little bit first. So I'm not going to do any more than just one example of this, because there's so many different examples you could do on this. But basically, you've got to know how to like put numbers together, right? Like terms, right? So I'm not going to combine the 3 and the 1 or the 3 and the 6, because they're not like terms. But I can add 1 and 6, that's 7. So this would be y equals, excuse me, and I might as well go ahead and write it as a fraction, -3/1x plus 1 plus 6 is 7. So there we go. Now I have -3/1x plus 7. And then I can graph it. So I'm going to go up 7. 1, 2, 3, 4, 5, 6, 7. So right here. And then I'm going to go down 3, rise -3, run 1, right? Rise over run. Rise -3, that means fall 3, run 1. Fall 3, run 1. Fall 3, run 1. Fall 3, run 1. So there we go. Very slopey, but it's negative, so it's going down. And there we go, there's my line. So the next two I'm going to do are the last two, and they're special cases. So if you can understand this first one, then it's very likely that you'll understand the next one even better, if not just as well. So this one doesn't look like the others because it's just got a number. It doesn't have an x at all. So this one you have to think about it a little bit differently. Since there's no x, it's just y equals 4. Well, if I wanted you to solve for y, you'd be done, right? Y equals 4, you're done. But as far as a line goes, it makes more sense when you graph this to figure out what's actually going on. So there's no x, which means that x can be anything. If there's no x, x can be anything. So what the best way to solve these, and this is kind of a different animal, so you have to do it a little bit differently, so just bear with me here. If x can be anything, then just make up a number, right? So what if x is 0? Make a little t-chart over here. If x is 0, what would y be? 4. Y is always 4. If x is 1, what would y be? Well, 4. Y has to be 4. Y equals 4. That's the equation. So no matter what x is, y is stuck. X can be anything. Y is stuck. And that's how these equations work. If it's y equals, the y is stuck, the x can be anything. Well, let's graph those 2 points and figure out what the line looks like. So if x is 0, y is 4, 0, 4, I wouldn't go left or right. I'd go right 0, so I'm not moving, right or left, and then go up 4. 1, 2, 3, 4. So there's a y-intercept of 4. Then also, when x is 1, y is 4. Well, if x is 1, that's right here. 1, 2, 3, 4, that'd be right here. So now you can see the pattern. So remember, all you need is 2 points for a line. So my line would look like this. And so many people get these confused because they're trying to think like, okay, y equals 4, then it should be parallel to the y-axis, right? This is the y-axis. This is the x-axis. If it's y equals 4, shouldn't it be going up and down? Mr. Kyle, what? This makes no sense. Well, actually, the reason why people get this confused is that the y-axis is actually x equals 0. So the reason why people get this confused is because they think the y-axis is y equals 0, but it's actually the other way around. It's really weird, but it just works out that way. Y-axis equation is actually x equals 0. The x-axis is y equals 0. They're flipped around. So the best way to make sense of it is to just do a quick t-chart. If y equals 4, y is stuck at 4. But there's no x. If there's no x, x can be anything. Kind of like whenever you have a rule, there's like a list of rules, and you're like, oh, there's no rule that says I can't do this, but it's like, you probably shouldn't be doing that. It's like, oh, but you didn't say I couldn't do that. That's kind of what's going on here. So like, if your parents were like, oh yeah, they never told you that you couldn't put gum underneath the table, even though you're told not to do that at school. It's like, if you put gum under the table and your parent saw you, they'd be like, what are you doing? You shouldn't be doing that. And you're like, well, you never said I couldn't do that. Right? That's kind of what's going on here. So if there's no x, there's no rule for x. There's just y equals 4. So if there's no x, you can do whatever you want with x. It can be whatever number your little heart desires, which is why it makes the line that it makes. So I'm not going to spend too much time on this next one. It's the same exact principle. So there's no y, which means y can be anything. Y can be anything. But there is an x, right? So x is stuck. So let's do a little t-chart again. X, y, right? Now x is stuck. So if x is -2, which it has to be, y can be anything I want it to be. So obviously I'm going to want to do easy numbers because y do like 100. It's not even going to fit on this graph I have, right? 0 and maybe 1 again, right? So 0 and 1. Super, super original. Just really easy numbers. Don't make it harder than it needs to be. Remember, math works for you. You don't work for math. Okay, so anyways, plug this in real quick. I forgot I didn't plug in my laptop. So we would have -2, 0, -2, comma 0 is right there. Okay? And then -2, comma 1 would be right here. So now if I connect those 2 points, that makes a vertical line. Which kind of makes sense, right? The last one was a horizontal line and it was y equals. This one is x equals, so it's going to be different, right? Y equals is different than x equals, so the 2 lines are going to look different. So if it's y equals, it's horizontal. If it's x equals, it's vertical. I wouldn't try to memorize that. I would just say, okay, x is stuck. If x equals -2, x is stuck. So let me just think of 2 points real quick where x is -2 and y is something. And then graph it. Graph those 2 points and then connect the dots. And then, you know, keep going and make a nice line out of it. And then there you go, you're done. So this one would be our line. And that's it. That's all I've got for you today. So if this video was helpful, go ahead and throw a like and a comment in below if you want to ask me a video, like any kind of video that you want me to do next. I've got several in the pipeline, but any topic that you can think of that you want me to do a video on, just let me know in the comments below. Also, I have a free guide. It's called the 5 Math Mistakes Everyone Makes and How to Avoid Them. It is on my website, myersmathematics.com. You just go there and grab it for free. I'll put the link in the description below. And have a blessed day, y'all.